Okay, Unit 10 is all about circles. In this first lesson, we're going to learn about just kind of the parts of the circles and the vocabulary that's associated with it. And so this first line that we're going to look at are some words that we're not familiar with. We know center point. We know what a radius is from the center out. We know what a diameter is, double the radius, or the line that goes through the center touches on either side of the circle. But then there's some other words that we need to talk about. The first thing that we're going to look at here is this line that I've highlighted in pink, and this is called a chord. A chord attaches the circle at 2 points, but doesn't have to go through the center. It's also a segment. So underneath here, I want you to write segment to remind yourself that it's going to stop on either side of the circle, but it doesn't necessarily have to go through the center. The next line that we're going to talk about is this one here in green. Notice that it does touch at 2 points, but the difference is that it keeps going outside the circle and the chord stops. This is called a secant. So the difference between a secant and a chord is a secant is a line, which means it never stops, and a chord is going to stop. It's a segment. The next one that we're going to talk about here in blue, okay, this line is called our tangent line. The difference with this one is that you can see it only hits a circle at 1 point instead of 2. The point where the tangent line hits the circle is called your point of tangency. Okay, so chord hits at 2 points, but it stops, it's a segment. Secant hits at 2 points, but it keeps going, it's a line. And tangent hits the circle at 1 point at the point of tangency. So let's practice this a little bit down here. Going back to some of our old vocab, we know our center point is right in the middle. We can call that point O. It wants us to name all of our radii. Remember, radii are segments, so we have to label them as segments. So I'm going to highlight all the radii I see. I see ON, I see OR, and I see OM. I see those three right there. So R, ON, and OM. Then chord, remember it has to hit at 2 points. Can go through the center, doesn't have to. So I see MT, because technically MT could stop. I also see MN, so I'm going to color code that. So MT, and the way I can show that it's a chord and not a secant is I can show that it's a segment. And also MN. Yes, diameters are chords, but all chords don't have to go through the center. Okay, the next one we're going to look at here in the purple or pink color is the secant. So remember, secant has to keep going, so that's why I'm going to highlight all the way through. So the way we can show that it's a secant and not a chord with MT is that it keeps going. Put the arrows at the end, and that's the only one I see. Diameter has to hit the circle at 2 points, and that is right here at MN, and it is a segment, so it stops. Let's see, I did the secant in that pink. Let's go ahead and highlight that just to remind yourself. Tangent line has to hit at 1 point, so I only see one tangent line here at PS. Notice I said tangent line, so it is going to keep going. And then that point where the tangent line PS hits a circle is at point Q, and that's your point of tangency. Okay, so let's practice some questions with this. The first theorem we're going to look at on this lesson is that if a line is tangent to the circle, so looking at this tangent line here at AB, touches at point B, if it's tangent to the circle, then it is perpendicular to the radius drawn, which means we have a right triangle. Remember, right triangles are never going to leave us. We're always going to have to use them throughout the year. So if we have a right triangle, then that means we have two sides. We can use Pythagorean Theorem. So we can say 5 squared plus 12 squared, because that's our A and our B. 5 squared is 25. 12 squared is 144. We can add those two together, and that's going to get 169. And we can square root both sides, and C would equal 13. Now, it's not asking for the hypotenuse. It's asking for part of the hypotenuse. And a lot of you look at this line here in green and say, oh, well, it's cut in half. But it's not, because we know all radii are the same. So if BC is 5, so is this segment here. And if the whole thing is 13, then step 2 would be to say 13 minus 5, which would give us 8. And that's what x would equal. Okay, the next one here, if two segments from the same exterior point are tangent to a circle, then they are congruent. So in terms here, if tangent line AB and tangent line AD meet up at point A, then that means they are congruent. So that means we can say that 2x minus 13 is equal to 48. Those two segments are congruent. So now we can solve and say 2x equals, add the 13 over, 61. Divide by 2, x is going to equal 30.5, okay? And so now we can look at a couple other things. Measure of angle ABC. Well, let's highlight that in purple. We have a tangent line coming together at a radius. We just talked about that that would make a right angle. And BC is a radius. So we know that this right here is 48. We have 2 of our 3 sides, so we can do Pythagorean Theorem. I'm going to squeeze that in here. We know that 52 is our hypotenuse because it's across from the right angle. So we can say a squared plus 48 squared equals 52 squared. And we subtract our 48 squared, so a squared would equal 400. Square root that, and that's going to give us 20. Okay, so all of our radii equal 20. And if we go from a radius to a diameter, we know that we would just double it, and so that would give us 40. Last example here is just looking at naming, and you're going to have to do this on the next activity. So let's look here. OC. OC starts at the center, goes to the edge. We know that that's a radius. And if you want to pause the video and try this part on your own and then check in your answers, that would be great too. ED is from this side of the circle to the other side of the circle going through the center, so we know that's a diameter. AB is right here, touches a circle at one point, so that's a tangent line. And then the measure of angle, let's highlight it, OC to A. We have a radius connecting to a tangent line, so we know that's a 90-degree angle. Or we could say it's a right angle because they want us to name it. And that's the parts of a circle.